Okay, welcome to Chapter 12 Homework, where this one we actually have a limited number of questions we can use and only 6. Nice. So, let's start this out with a basic finding the critical F value. So, using our chart. Now, remember this with our sample sizes. We must subtract 1 from them. So I have in my numerator 11 and my denominator 7. So that means we're going to be going through 10 and 6. We also have a two-tailed test and the significance level is 0.10. Now, if you recall from your book, you have 2 tests. You have the 0.01 and the 0.05. But notice both of these are one-tail. So that means when it's asking for two-tail, we're going to divide by 2. And of course, 0.10 divided by 2 should give you 0.05. So now we're going to find our numerator and denominator. So again, 11 minus 1 is 10. We'll make it a pretty pink color. And our denominator is 7 minus 1 is 6. Okay, next, we'll go and find the number that they both cross at, which is 4.06, and we're going to enter that in. That should be our critical value. And that is it for question 1. Yay! That was fun. Alright. Now we get to have more fun. Arbitron Media Research Incorporated conducted a survey of the iPod listening habits of men and women. One facet of the study involved the mean listening time. It was discovered that the mean listening time for a sample of 10 men was 42 minutes per day. The standard deviation was 16 minutes per day. The mean listening time for a sample of 13 women was also 42 minutes, but the standard deviation of the sample was 15 minutes. At the 0.02 significant level, can we conclude that there is a difference in the variation in the listening times of men and women? Alright. So, real quick, they want to find, is there a difference between the two? They're not looking at which one's greater or less than, so that knocks out this one right here. We also know, again, the null always has the equal, and the alternative is always the opposite. So, that eliminates both of these because they're both the same symbol. So it means that one is going to be your 1. Again, we're looking for the standard deviations are the same. So, state the decision rule. Alright, so, again, the number that's going to be on top, that's going to be on numerator, is the one that has the standard deviation squared, going to be the larger. So, standard deviation, 16 minutes squared will be larger than 15 minutes. So that means our men sample will be on the numerator. Okay, and that means our women will be the denominator. So top, bottom. So again, to our F chart. Whoop. Right here. Alright, so we got 10 minus 1. That gives us 9. So we're going to do that in green. And we got 13 minus 1, which is 12. Now, am I on the right chart? That's going to be the key. I am not on the right chart. Remember, that was 0.02. So, 0.02 with an equal means we have a two-tail. So, it has to be 0.01. Let's re-highlight our numbers. So, 9 and 12. Whoop. There we go. Now find the cross, which looks like it's 4.39. So if it ends up being greater than 4.39, we know we need to fix it. Well, we know we go and reject, not fix it, sorry. Watching too much Bob the Builder. Can we fix it? Alright, so to compute the value, we're going to take the standard deviation of 16. So, taking our calculator, 16 squared divided by 15, because that's our standard deviation, squared, equals, it's going to be 1.14. 1.14, yeah. Check. We are correct. The formula for testing this when it's two variances is a lot easier. Now it's got compute the p-value. Alright, so again, we can use statistical software, or we can look up an actual p-value calculator. Which we're probably going to have to do with this one, because this one's not one that we can put in a Nova table yet. So we're going to go ahead and compute. So again, Google search is wonders, can usually find you a good calculator. So our ratio value is 1.14. The degrees of freedom numerator, this will be 9, and this will be 12. Again, they're looking at the degrees of freedom, not the actual sample size in this calculator. And we got 0.01 and calculate. So we're looking at 0.4068. It's not correct. Let's see if we can use .4043. Curious. Seems like this calculator is not calculating p-value correctly. Okay guys, seems like our p-value calculators, our statistic is not working for me. So I did a couple more p-value calculators. So there's probably a rounding issue that's happening because we did round our test statistic. So the only thing I can suggest, if this is happening to you, where the rounding is just a little bit off, where McGraw-Hill is not picking it up, please send me an email on this question and screenshot so I can see, and we'll get it fixed for y'all. Because, yeah, that is not right. But either way, our next one, interpret your decision. Well, since we are less than our F value or critical value, we do not reject. Again, we were only going to reject if it was greater than. So we can conclude that there is no difference. Because that's what we're going to try and test, was that there was a difference. Okay. Sorry about that, guys. I wish I could have get that working, but I think there is a rounding issue. It happens. This is not a software that works completely all the time. Okay, so a senior accounting major at Mid-South State University has job offers from 4 CPA firms. To explore the offers further, she's asked a sample of recent trainees from each firm. How many months did you work before receiving a raise in salary? Using the following ANOVA table, is there a difference in the mean number of months before receiving a raise among the firms? Use the 0.05 level of significance. Alright, now, if we could have done a ANOVA table in question 2, we would have gotten our p-value right there. But, unfortunately, that was not the case. So again, state our null hypothesis. So we're looking for if there's a difference. Again, nothing greater. So we're going to look at if they're all equal or not equal. Again, check. Alright, what is the test statistic? Here's our p-value, 0.022. See, I love ANOVA tables right now because they're the easiest of figuring out the p-value, the one that's been stumping us for a while. Okay, so we need to do the test statistic. So, for ANOVAs, remember, this is this fun little formula that we had. Well, that's a confidence interval. Never mind. So we need to find the test. So, where do you see the test? Is it in the ANOVA? Yes, 8.99. So, using our example, here's our item, 4.67. So we have calculated using our ANOVA table, our F statistic, test statistic, and our p-value. But we still need to figure out what is our F to see if we reject or do not reject. So keep in mind 4.67 is our test. So gotta go to our table. And we were using 0.05. So we need to go to that table. There we go. And we have our degrees of freedom. We have 3 and 12. So 3, 12 comes out to 3.49. So this is indeed greater than 3.49. So we are going to reject the null. So this means there is a difference. There we go. So that's question 3. A little bit easier because we got the ANOVA table. All right. Next, we have a study of the affected television commercials on 12-year-old children, measuring their attention span. In seconds, the commercials were for clothes, food, and toys. So this is going to bring some fun. So let's go ahead and click on the Excel data. And there it goes. So let's go ahead and do a data analysis on this. So, notice this. Now, if we try to do regression, which is chapter 13, let me highlight. It's not going to help us at all. So, we can't use that one. So, let's see here. See, group by rows. So we can use Excel to work for us. Okay. If not, we're going to do the calculations. Either way, we're going to have some fun. Okay, looks like that did not pan out as we wanted to do. Okay, sometimes I forget that I'm not recording both monitors, but it's okay. We're going to go ahead and knock out the Excel. Now, the data analysis for the ANOVA really works more with regression. So this chapter, we got to create our own again. So let's go ahead and knock out what we can. So again, we want to know if everything equals and not equal. Check. There we go. Next, we're going to create our actual ANOVA table. So, again, we're going to have to use our formulas. But we need the data. So, if you've downloaded the data, we're going to expand. And we need to find the grand mean. So the grand mean in itself, we need to take the sum file. Oh, not file. Always want to do file. Formulas. Auto sum. And we have a combined total of 32. Make sure that balances to what we have here. Yeah, it looks like it. So this divide equals this divided by 32. Okay, so we got about 42.5625. Nice. Next, after we find the grand, we're going to do find the SS total. Which the SS total is the sum of x minus x grand bar or grand mean. I'm just going to put x grand and all of that squared. Okay. And I'm putting that in the wrong thing because I didn't scroll all the way up. There we go. And squared. Alright, so this is going to equal power, parentheses, our number, which is going to be B2, minus x grand, which is 0.42.5625. Again, the reason why I'm doing this this way and not highlighting that cell is mostly because we don't have to fix every formula with highlighting that same cell. Now, if you want to take the time and do it so you can use this problem later on, you're more than welcome to. Comma squared. Okay. I'm going to bring this all the way down. And then we'll go on, basically take the total. So, auto sum. We have 4,615.88. So 4,615.88. So check. Let's see if our total is correct. Our total is correct. Nice. Next. We're going to have to figure out the sample mean, or the sum of squares error, SSE, which again is basically our random variation. So for this one, we're going to take the sum of x minus our treatment so we need to find the individual means. So let's find the individual means real quick. So that divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Food equals sum of that divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and then last, the toys. 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so there's our sums, or basically our means. And we're going to do this. We're going to equal our x, or again, our power. So let's put power first. Power B2 minus 28, comma, squared. There's those numbers. Then we're going to do the same. We're going to take equals power number. Whoops. Again, cannot do that. 40.9167, comma, 2. So a lot of decimals going on right there. Let's go down all the way to food, and then finish it off with toys. Again, remember to add the power. Minus 51.9091, comma, 2. There we go. And again, highlight and auto sub. So 1679.83. Okay, let's check. We are correct. And the difference between those two will equal treatment. So 4615.9 minus 1679.8. We left with 2936.1. Okay. Again, check. Oh. Looks like we have something going on here. Which is very odd. It's like I'm finding more errors as long as I go with y'all. Okay. So there's a rounding error or a rounding issue there, because yeah, that makes absolutely no sense. So there is a rounding issue. Alright, so let's return back. Let's figure out degrees of freedom. Which again, we have the treatments minus 1. So that's 3 minus 1, so that should be 2. And then in the number that we have, which is 32 minus 3, number of treatments. So we're left at 29. So 29 plus 2. Should be 31. There we go. So there's our degrees of freedom. So we fixed that part of the ANOVA. Next, our MS, mean squared, basically taking these two SS and degrees of freedom and dividing them. That's really all we're doing. So calculator. Again, 2936 divided by 2 equals 1,468. And sure move that. 1679.8 divided by 29. We're at 57.9. Okay, again, always check. Make sure we're okay. Turn. Now we just divide these two. And we're left with 25.4. Or is it two values? No. Okay. Two decimals, so 25.35. Okay. Check. There we go. Now we go on to compute the p-value. Alright, so p-value again. Okay, so let's see what we can do. We're going to try again with one of these and see if it actually works for us. So, 25.35. Whoops. Okay. Degree of freedom in the numerator was 2. We are left with 29. And we have a significant value 0.05. Calculate. We have like 0.00001. So basically, since I can only do 4 decimal places, 0.000. And we are correct. Yes. Alright, now we find the F crit, which again is from our table. And we have our degrees of freedom already. So let's pop up our book. We have 2. Make sure we're on the right table though. 0.05, 2, and 29. So it's going to really fall between these two. So let's use the one that's closest, 3.32. Actually, let's use 3.39. Okay, turn. Yeah, so we'll use the closest one that comes to it. So 3.32. I was thinking that maybe a little bit like we don't go over our than the degrees of freedom, but no, 3.32 is closer. So it's going to be more realistic to that. Again, when they do gaps in the table, that means there's probably a very minimum change, what numbers related to it. All right. So what is the test statistic? It is now 25.35. There you go. Return the slab. 0.000. Check. There we go. And we're going to the decision of the null hypothesis. It is definitely greater than 3.32. So we are going to reject. And that there is a difference. So check. Yep. Next, it wants to define critical value. Here we go. So we have to find the interval difference between lines of clothes and food, clothes and toys, and food and toys. So, this is using our fancy formula right here. Yay! So this is why we needed to calculate the means in the first place. But we do need to come out with the t-value. Okay, so new table, new fun. Let's get busy. Alright, so the interval for the difference between lines, clothes, and food is from what? Well, let's go ahead and get out our Excel. We're going to try and use this as best as possible since we do use MSE. Which my MSE is this 57.9. So this is going to equal we're going to put the formula up here. So we're going to put size 1, size 2, t-value, and MSE, which again is 57.9 for us. Here we go. We're going to calculate it out. Now, we also need to know the means. But we're going to go ahead and put that formula in. You know it's x1 minus x2. So that's the one that we got. And we'll change it. Or let's go ahead and just go ahead and put it in. Mean 1. Mean 2. So 28. 44.9167. So formula in itself. Go on first. Have to take our means. Subtract the 2. So we come out with this number. We're going to use that number later. Then equal now to our t-value. Multiply the square root of our MSE. Multiply by 1 divided by sample size 1 plus 1 divided by sample size 2. Okay. Then we have our positive and our negative. Again, you can set up the table however you like. So this is going to equal wherever this is plus this. And this is going to equal this minus this. Okay, so now we need our sample sizes. So again, we had 9. And here we had 12. Alright, the only thing left now is compute t-value. So what would t-value be? So remember, degrees of freedom are still equal to n minus k, which we did. That's 29. So find our t-chart. Go to our book. T-value. Here's our t-value. We're doing a 95%. So 95%. Highlight. And go find 29. 2.05. Notice this is not going to change because our degrees of freedom is n minus k. So 2.045. And boom. So, for our interval, typically would start with the lowest, which is negative 23.7784 to negative 10.055. Okay, let's check. See if our computation did not come out correctly. Huh. Turn to the question. The question is, why did it not come out? Are we still dealing with a rounding issue? See if I do it the other way. So now it did that correct. Now it doesn't have the 10.06. They're being very specific on how they get these. Alright, so it looks like it is off on the decimal on itself. Sometimes we have to play with these. There we go. See, sometimes that's the fun part. It is slightly off, so thus we have to play a little bit and find that exact number. And notice how, even though I had it the correct one, it was switched. So they want the highest number to the lowest. That's okay. We can go with that. So know that we're probably going to have some rounding issues. So we're probably going to round this to 2 decimal places and see if that works. So let's see if that was going to be the case. Yeah, that would have probably came out exactly like how they wanted. This would probably been a little bit more fun, but we're already there. Okay, so we're going to do that with the means. We're going to do 2 decimal places and see if that works out. Next, it wants nose, clothes, and toys. So 51.91 is mean 2. That sample size was 11 compared to 12. Nothing else changes. We're looking at negative 16.92. Negative 16.92. And negative 30.94. Make sure I put that in correctly. No, I did not. For some reason, I put... There we go. Check. See? Again, a little rounding issue. So we're trying to fix this. So let's see. So you're going to be 9-1. So let's try 9-1 first. There we go. So again, just because of how McGraw-Hill rounds, it's just our calculations are slightly off. Alright. Food and toys. Last one. Let's see if we get this one close. So, we know it was 44.91. So, we're going to do 92. Again, try and get it close. Sample size 2 is still the same. Sample size 1 changes to 12. So we have negative 0.49. And negative 13.49. See if we're close. And again, y'all saw that coming, huh? Let's see, go down one. Nope, this time it's not that close. Let's try going up. There we go, up that time. See, as you can see, we're just slightly off, but we're okay. So, when we look at which pair of means are statistically different, the only way that they cannot be different is if 0 runs between our interval. None of them have it. This one's close, but it's not it. So ours is going to be all above. Yours may be different. Remember, these are algorithmic, so it could be a little bit different. So, if it does have 0, that means that that's not different. The way that they got this, you either have 2 that are going to run through 0 or all the above. Whew, that was fun. It was fun in the aspect that rounding is key. So don't get frustrated. Just remember that sometimes you have to figure out the numbers as we go. Okay, so here's a little bit easier one. We don't have to actually go through each one, but we do have to still do the ANOVA table. So again, we have 2 treatments minus 1. So then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 minus 2 is 12. So we're at 13. Notice that the total is always basically n minus 1. There you go. I just knocked out degrees of freedom because that was a little bit easier. Now we got to do the total and treatment. So let's go ahead. You can either, if you've already created an Excel that does all the calculations, you can. Or we can just simply take out these 2. Notice that they're a little bit different. That's fine. Again, we can change it up. But we're going to go ahead and leave it like this. So let's find that grand. So again, equals sum of these plus the sum of these. Enter 540 and then divide it all. So we'll put these in parentheses because of order operations, and divide it by, again, 14. So our grand mean is 38.5714285. Now, again, to find the total, we have to take all these numbers and basically subtract from the grand and square it. So, whoops. So real quick, insert. I want to take this equals this one minus 38.57. We're going round. So again, since we're rounding, we may have some issues. And make sure we do power, comma, 2. So there's 6.6049. There we go there. And that equals, since all we're doing is trying to find the total, we're going to go ahead and do two formulas. So again, don't forget your power, minus 38.57, comma, 2, keep going until it probably zeroes out, which means it's basically the same number. There we go. So we should have 14. We do. And sum it. Awesome. So ours is 59.4286. So again, let's go ahead and put that in. 559.83. Okay, it is 4. 9.4286. Let's see if we're close. Forgot rounding. Nope, they took it. Yay. So now all we gotta do is find SSE. Which again, remember, we had to take the mean of each one of ours. So equals sum these numbers divided by how many? 1, 2, 3, 4, 5, 6. 6. Did the same. Equals sum. I don't know why I got parentheses. Sum of this divided by how many? 1, 2, 3, 4, 5, 6, 7, 8. There's our two means. Then, again, equals power of that minus 33.67, comma 2. Go, and then this will equal power, this one, minus 42.25, comma, 2, and go again until it starts repeating itself, which it kind of did. There we go. Okay. Then we find the sum of this. So, auto sum 306.8334. Check. Again, we may have rounding. Good. Now we find the difference. So calculate. Calculator. 559.42.4286 minus 306.8334. 252.5952. Oh, I totally butchered that. 2525952. There we go. We had some transposition of numbers. Okay, check. See, all good. Again, use that check my work feature. Learn the stuff. So, we know NS is not going to change for that one. Since it's divided by 1. Take 306.8334 divided by 12 is 25.5695. And check to make sure our next step is good. Yay. Then our F statistic, 252.5952 divided by 25. So divide 2, our F statistic, looks like we do 2 decimal places, so 9.88. Oh, it does want 4. Okay. There we go. P-value, again, we're going to use the calculator. So 9.8788. We had 1 and 12. We are under looks like 0.01. We're going to compute based on that one since that's where we're going to find the crit. Calculate. Looks like 0.084 or 85. There we go. So, yeah, I have no idea why the p-value didn't work on the previous ones. On the previous one, because we're got the right calculator. Just happens again. It could be just that small rounding issue that's just throwing everything off. Okay, now our critical value. Let's go to our F statistic. F table, make sure we get the 0.01. And we're going to look for 112. It looks like it is 9.33. So it is correct there. Here, they're looking for more decimal places. Wow. They're just being fun there. So, okay. So they want to be a little bit more. So we're going to have to go a little bit more in depth, which is interesting. Huh. So we know it is correct at 9.33. There's our crit. So it does come out the same. So I wonder if this will go to 0.05. So let's try both of those. So, because sometimes they may do that. They may do it based on the regular 4.75. I doubt it. Oops. Yeah. So they want a closer one. So let's just do 9.333. See if it's just a 3 repeated. No. Alright. Let's play a little bit with the Excel. Because why not? We've already calculated everything except for this. So let's see. Data analysis. Let's go single factor. By columns. We're going to do 0.01. We'll tell it to put it right there. Aha! But it's not exactly right. So it's between the group, within the group. They come out to a correct value of 8.86. Oh, 4 decimal places. 8616. Still off. Okay, so we're close. I think we're on the trail, guys. So the question is, why is it doing it that way? So we're going to try this again. Input, we're going to do another data. I'm going to go ahead and remove all this. So just with the table. Let's try it this way. Ah, that's probably what happened. Okay. So, okay. There we go. There's 1213. There. It looks pretty much within our number range that we did when we calculated. So nice. So use single factor. There it is. 9.3302. 9.3302. Check. Yay. So, learning things as we go. So again, using a single factor when there's only 2 actually came out with our whole table. And there's even our p-value. Wow. So we did it the long way, and now we know the short way. If I knew the short way, I would have made it easier for y'all. Alright. So, using the t-test from Chapter 11, compute t. Okay. So again, we know that's going to be 12. I guess we're using the 0.95. Our compute the t-test from chapter 11. Okay, so let's go find the t-test. Yeah, she said chapter 11. So make sure we get the right one. Ooh, I think this is going to be the fun one. But it doesn't say exactly which t-test. Huh. So, we're going to start with this one because we don't know the population. So, we're going to do this one real quick. So, Excel. Or there may be a sneaky way in Excel. So, I'm going to zoom out real quick. We're going to do a data analysis. And look, there's a t-test. So, we're going to do a t-test assuming that they're equal variances. Click OK. There they are. Variable range 1. Variable range 2. Okay. Output range. I'm going to tell it to put it over here. Let's click OK. Okay, there we go. There's our t-stat. See, negative amount should indicate by the minus sign 3 decimal places. So back. So negative 3.143. Let's see if that is correct. That is. Woo! Using Excel now with that new data analysis that we have. Again, I am learning as we go. So, are we going to reject? We are going to reject. It is greater. Barely, but it is greater. So that means there is a difference. Slightly, but there is. Okay, there's 5. 6. Alright, so the Postal Service sorts mail as Priority Mail Express, Priority Mail, First Class Mail, or Standard Mail. Over a period of 3 weeks, 18 of each type were mailed from the Network Distribution Center in Atlanta, Georgia to Des Moines, Iowa. The total delivery time in days was recorded. Minitab was used to perform the ANOVA. The results are as follows. Okay. Using the ANOVA results, compare the average delivery time for the 4 different types of mail. Identify the null. Well, again, null is always equal, so out of the choice of the 2, we will only take the equal. And alternative means that at least one mean is different because they cannot be all equal. So check to make sure you got those two. Awesome. What is the decision rule? Use 0.05 significant level. Basically, what is our F critical? Well, we got degrees of freedom of 3 and 68. We are using 0.05. So now on the table again. Okay, critical value. We are on 0.053 and all the way to 68, which probably is going to be 2.76. So check. We are right. Again, go to the closest one. Alright. Using the 0.05 significant level to test if evidence suggests the means are different. Wow, this seems so much so much better than what before. So we're at 2.50. It was 2.76. It is in fact less than. So we do not reject. And there is no difference. And that is it. So that's number 6. So that's homework for chapter 12. Hopefully you were able to follow along. Notice that, again, I had a little hiccups, but we did learn and grow now that we have that data analysis. And if you don't know how to put that in Excel, do a real quick look at, I believe I did that for chapter 13 lecture, as the homeworks are a little bit behind. Okay, let me know if you have any questions, and I will see y'all for the next homework video.